Math 8, Unit 4, Lesson 4, Direct Variation, y equals mx. Okay, this in the last lesson we discovered that if we were to graph an equation and check the slope of that line, we would end up getting a slope that is equal to the coefficient of the x term. For example, here, if we graph 2x, we get this line. I can draw more points, and it does have a slope of up 2 over 1, so the slope is 2. What we discovered is that the slope is the same as the coefficient of x. So that was the major thing from yesterday's lesson. And this is true for all of them. Y equals 2x, the slope is 2. Y equals 2/3 x, the slope is 2/3. Y equals x, the slope is 1. Y equals 3x, the slope is 3, etc. So we have four things that represent the same thing. They're just different representations. We've got rate of change, which you calculate from a table. Just making a quick demonstration of this. Going from 11 to 6 is going down 5. Going from 1 to 3 is going up by 2. And the slope here would be the change in y, which is -5, divided by the change in x, 2. The slope's -5/2. We can do slope between points. For this, you use the difference quotient. You fill the y's up top, 12 minus 6. And since I went in that order, my x's need to go in the same order, 3 minus 1. This gives me 6 over 2, which is a slope of 3. Next, if we have a graph, we just do our right triangle, and we're going to do rise over run. We need our right triangle to hit lattice points in the grid. And right here you can see up 2, right 3. So that's a rise of 2, run of 3, slope is 2/3. Now, based on yesterday's work, we know that the x coefficient, the coefficient of the x term, is my slope. So the slope here is going to be 3. It's just the number in front of x. Okay. When two quantities, x and y, are proportional, the relationship can be represented by a direct variation equation, y equals mx, where m is the constant of proportionality. Also, m is the slope. The graph of y equals mx is a line with a slope of m that passes through the origin. So, review from 7th grade, a direct variation or proportional relationship graphs a straight line that goes through the origin. I want you to notice it goes also through the point 1 comma m. That's because if the slope is m, you can go up m and over 1. That's just equal to m, and that will give you a point. There'd also be the point 2 comma 2m and 3 comma 3m for every value for all of those when you have your value of m, your slope. Okay, the cost y measured in dollars for x gigabytes of data on the internet plan is represented by y equals 10x. Graph the equation and interpret the slope. Now, previous to this, we would have to graph using a table, but we have learned that this has a slope of 10. So my slope is 10. I just need to create a graph, goes through the origin, and has a slope of 10. All right, first, my x-axis, I'm going to label it gigabytes, because x gigabytes. And I'm just going to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, good. For the y-axis, y is cost in dollars. So I'm going to put cost measured in dollars. And since the slope's 10, these numbers are going to get big fairly quickly. So I'm going to count by 5s and label every other one. Looks like you can get all the way up to 60. All right, and then with graphing these, my slope's 10. I need to treat that as 10 over 1. I can go up 10 and over 1. And then I can do it again, up 10 and over 1. Up 10 over 1, up 10 over 1, up 10 over 1, and up 10 over 1. until I run out of space, and then I draw my line. This line represents the cost y in dollars for x gigabytes of an internet plan, represented by the equation y equals 10x. So that is quite a bit of a time saver. Okay, the weight y of an object on Titan, one of Saturn's moons, is proportional to the weight x of the object on Earth. An object weighs 105 pounds on Earth would weigh 15 pounds on Titan. Write an equation that represents this situation. All right, first, we are told that the weight on Earth is x, then the weight on Titan is y, and 105 pounds on Earth is 15 pounds on Titan. Now we would need to find slope here to write an equation, because the slope's right there in the equation, but we only have one point. Well, the fact that it is a proportional relationship, all proportional relationships go through a special point called the origin. Since every proportional relationship goes through the origin, these also go through the point 0, 0. And this gives me enough I can calculate slope. This is 15 minus 0 for the y's, 105 minus 0 for the x's, and that is a slope of 1/7. So the equation that represents this situation, y equals 1/7 x. How much would a chunk of ice that weighs 3.5 pounds on Titan weigh on Earth? Now pounds on Titan is y, so the y is 3.5 here. So we're going to take y equals 1/7 x and replace y with 3.5, and then we just solve for x. Multiply both sides by 7 over 1, and we get 24.5 equals x. So the answer here, 24.5 pounds. Okay, next example. The distance y, measured in meters, that a 4-person ski lift travels in x seconds is represented by the equation y equals 2.5x. The graph shows the distance that a 2-person ski lift travels. Which ski lift is faster? All right, here we're going to be comparing their slopes. The slope for the 4-person ski lift is 2.5. That actually means the 4-person ski lift is going 2.5 meters per second. Or sorry, the 4-person. The 2-person ski lift is represented in the graph. Yeah, 4-person was y equals 2.5x. In the graph, if we do a triangle for slope, it goes up 4 and over 2. That is a slope of 2. So the 2-person ski lift is 2 meters per second. So which ski lift is faster? Well, 2.5 meters per second is faster than 2 meters per second. So the answer would be the 4-person ski lift is faster. Okay, let's make further comparisons here. If we graph the equation that represents the 4-person ski lift on the same coordinate plane as the 2-person lift, we can compare the steepness of the graphs. What does it mean in the context of the problem? All right, you should recognize or notice that the red line is steeper than the blue line. The 4-person ski lift has a steeper slope than the 2-person ski lift. This steeper slope means that it has a bigger slope number. Now, since the slope number represents how fast it's going, it means it's going faster. So here, the steeper line equals faster ski lift. In general, a steeper line means a greater slope, and a greater slope in the context of a problem usually means something is changing faster. What's changing here is the location over time, which is essentially speed. If we had another ski lift like this blue one I just drew, you should recognize that it would have a slower speed than either of them. If I had another one like this green one I just drew, that would have a speed greater than either of the others. Quite a bit greater, actually. Okay, let's use a graph or table to determine whether each relation shows direct variation, which means is it proportional. If it does, write the equation. All right, for proportions, gotta bring out some memories of 7th grade math. If it's proportional, we can compare y to x and get the same thing on all of these. And actually are all equal. 5 divided by 1 is 5, 20 divided by 4 is 5, 35 divided by 7 is 5, and 50 divided by 10 is also 5. So this is proportional. It does show direct variation. And the equation, the slope ends up being, well, it goes up by 3 and this goes up by 15. The slope is 5, so y equals 5x. That is a direct variation. Okay, next example. If it's going to be proportional, it's got to have the same rate all the way across. So this would be 6 compared to 2, 8 compared to 4, and 10 compared to 6. These are not the same. So I'm going to say no on this one. These are not proportional, so they don't show direct variation. Next, we've got a two-person race represented in a graph. Now, this graph is a straight line, that's good, but it doesn't go through the origin. So no, because it doesn't go through the origin. All proportional relationships will go through the origin. Curiosity rover at top speed. Alright, this one is a straight line through the origin, so yeah, it's proportional. Now we just need to come up with the equation. We need to know the slope. Looks like the slope, if we go between these 2 points, from 1.5 up to 4.5 is going up 3, and from 1 to 3 is going over 2. So the slope is 3 over 2. Also acceptable to have 1.5. So y equals 3 halves x or y equals 1.5x. Okay, in the practice, first determine whether x and y are in a proportional relationship. That's a yes-no. If not, tell why. So if it's a no, let's say why. Why isn't it proportional? That's like right here. Well, it's not proportional because the rates are different. Or it's not proportional because, let's see, we were way back up. No, there. I have another example somewhere here, but I won't worry about it right now. If it is, you need to write the equation. You know, your y equals kx, not k, mx. You find the slope, and you can write the equation. Number 2, you're going to be solving a proportional unit rate problem. First one dealing with kayak. Second one, you're comparing the mileage in a car with the mileage in a truck. Number 3 is a review of solving for y. Number 4, solving with absolute value. Number 5, on this you're calculating a missing thing from slope. So you will use the slope formula. So do the difference quotient, fill the y's in on top, fill the x's in on bottom. And one thing that I recommend here is represent the slope as a fraction, because now you can do cross products and then solve it that way. So that's not done, that's just set up. Number 6, you're told about 3 degrees in a triangle, find out what they are. Number 7 is about nonlinear slopes. It introduces what a secant is and a tangent line, and it has you estimate the slope of a tangent using 2 secant lines on the y equals x squared graph you see pictured. And then number 8, you're going to use the situation d equals rt, and we're going to plug in different things for d, r, or t, and talk about what kind of relationship they form, whether it's proportional or not proportional.